Hello everyone! We have created a detailed tutorial that explains how to model, simulate and control a differential drive robot in ROS2 and Gazebo. The robot is shown over here. The robot consists of the body, represented by this red box over here, two actively controlled wheels, represented by these yellow cylinders, and an additional passive caster wheel that can be seen over here. The caster wheel is passive and it's used to support robot body. The robot is controlled by using a separate node that's used to communicate the keyboard keys that are used as commands to the actual simulation. For example, over here in this terminal, I'm running the control node. If I press O, the robot will rotate like this. Then if I press K, the robot will stop. If I press I, the robot will move forward. Similarly, the robot can move backward. If I press J, the robot will rotate around its axis. If I press L, it's going to rotate in another direction, and you can actually steer the robot and move it and play with it by just pressing the keyboard keys. So if I want to go here, then turn left, then go straight, I can do that. I can go wherever I want. We have created a complete manual explaining how to model the robot and simulate it in ROS2 and Gazebo. Here's the manual. The manual is 8-page long. In the tutorial we created, we explain all the steps that you need to perform to create this robot and its simulation. Furthermore, we explain how to define the robot geometry and parameters in the robot.zacro file. Here's the robot.zacro file. Then, we explain how to define the additional gazebo parameters in the robot.gazebo file. And finally, we explain how to write a Python ROS2 launch file that combines all the nodes, that launch them together and displays the complete simulation in Gazebo. A link to this tutorial is given in the description below.